We have already seen how to work with Java using Snowflake Java JDBC connector and automate data loading from RDBMS to Snowflake as one of the use cases. We have also explored and learned how to use Snowflake ODBC driver and bring data to Microsoft Excel sheet and build reports. But what if you need to interact with Snowflake using Python and don't want to use either of these two programming interfaces? What if you want to integrate your existing workstream which is developed in Python to perform operation on Snowflake Cloud Data Warehouse? You don't want to have dependencies on JDBC or ODBC drivers and needs entirely pure Python package which can be installed using pip on Windows or Linux or Mac OS operating systems. To solve this problem, Snowflake has a Python connector and that support for Pandas and very rich extension to build a powerful application using this connector. This makes a Python developer's life very easy. And if you are a business analyst having extensive knowledge on Pandas library, you can do wonders with this connector. Then many of you will have following questions in your mind, which this video tutorial will address in detail. How to install and configure Snowflake Python connector on your local machine. The Python API, its configuration and extension which helps you to interact with Snowflake Cloud instance. Different authentication approaches like key pair or a single sign-on. How to run DDL and DML operation using Python API and its extension. Data from Snowflake environment and using them as a Pandas data frame. Asynchronous connections and managing background queries if you have a very unique use case. Data loading to stage location via Snowflake Python API and automate your data loading use case. So if you want to learn how to interact with Snowflake using Snowflake connector for Python from your local environment or from your server and become more efficient in developing data solution, stick with me until the end of this video. Welcome back to my channel Data Engineering Simplified and to this real jumpstart course for Snowflake Data Professional. The last 23 episodes in this series already covered history to architecture, data loading, micro-partition, time travel, cloning, stream, task, role and role hierarchy, stored procedures, functions, views, information schema, and many more important concepts including end-to-end ETL examples. We already covered JDBC and ODBC driver in part 1 and part 2 of this episode 24 respectively. And the part 3 of this episode 24 will deep dive into Snowflake connector for Python and build a working knowledge about installation, dependencies, connection, and configuration parameters. We will also cover different authentication mechanism followed by two important objects like connection object and cursor object and how to perform different operations like DDL, DML as well as asynchronous queries, working with Panda and how to load data from your local environment to a stage location. We will practice everything using Snowflake free trial edition and have hands-on exercise to cover all the concepts listed in this slide. So let's start now. Before we move next, let me ask this. Do you want to have mastery in the Snowflake Cloud Data Warehouse? I believe you should be because there are many amazing opportunities available if you are familiar with the Snowflake Cloud Data Warehouse system. I have been adding a lot of great content to help the Snowflake community. The response I received from my audience much exceeded my expectation. People are getting certified on their first attempt and scoring nearly 100%. My free content is used by data engineers, data lead, architect, and even data managers. You don't need to buy any expensive courses. Check my playlist. It includes almost everything to make you a successful Snowflake data professional. So, if you find something useful in this content, please press the like button. Leave your opinion in the comment section or send me a direct message on Instagram. Before we deep dive and understand how we can install the Snowflake connector for Python, let's understand the Python version requirement for Snowflake. The Snowflake connector for Python requires one of the following supported version of Python: Python 3.6 or 3.7 or 3.8 or 3.9 or higher. Snowflake connector for Python is installed by pip, the standard Python package installer and manager. I already have Python 3.9.1 installed on my machine, and I am going to use VS Code to demo the Snowflake connector for Python installation. If you would like to follow along, make sure you have the latest Python installed in your local environment. I will use a terminal or a command prompt from VS Code. So if you would like to follow command-based approach to install Python, you can always refer this video, and it is very easy to follow that. So here I am in my VS Code editor, and all the files which I am going to refer is kept under a folder called ch24.3-python. You can also create a folder and keep all your Python programs, requirement.txt and everything inside a folder, so it is more easy to navigate them. Now let me minimize my file explorer. Let's go through step by step and understand how to install Snowflake connector for Python. So first I am going to check what is my Python version. It has to be 3.6 or higher. So my Python version is Python 3.9.1. I am going to create a virtual environment, and once it is created, I am going to activate it. There are many videos which will help you to understand what is the virtual environment. Now I am going to create a virtual environment because I don't want to disturb my existing installation on my local machine, and I want to isolate everything for this demo. So I can copy this command. So it says Python -m followed by virtual environment and the name of the virtual environment. You can give any name as per your convenience. So my virtual environment is created successfully. If I have to verify how does it look like, I can click on this file explorer. Here I can see a new folder with name my_vnv01 is created, right? It has a bin, it has a library and everything. So this is an isolated Python workspace for me. Now I have to activate this virtual environment. For that, my command looks like this. And the moment I activate that, you can see my command prompt change from my virtual environment name followed by $. I can again check my Python environment here. So it is the same 3.9.1. Good. Now my environment is ready, and now I would like to install Snowflake connector for Python library, and that I will do it using the requirement.txt. So let's review our requirement.txt first. So the library which I want to install for my Snowflake connector for Python looks like this in line number 3. It says Snowflake-connector-Python, and it has a dependency on Panda, and it uses another library called PyArrow, which has to be 8.1.0. There is alternate approach which you can also follow. You can simply include Snowflake connector for Python followed by Pandas and followed by PyArrow. However, while doing that, I got this warning which says that you have incompatible version of PyArrow installed with 9.0.0, which is the latest version, and it says please install a version that adhere to PyArrow 8.1.0 or 8.0.0. That's why I am going to choose this set of dependencies for this demo. Now, if you have already used requirement.txt in your Python project, you must be familiar with this syntax. So I'm saying install all the dependencies by referring this requirement.txt. Let's run that. If there is an issue, it will end with an error. However, in my case, there is no issue, and it is just giving me a warning. My pip version can be upgraded. I can ignore this warning and I can verify whether my installation is done successfully or not. For that, I can run the pip freeze, which will help me to know what all dependencies are installed. Okay, so let me copy that. And here I can see my Snowflake connector for Python is installed. My Pandas 1.4.4 and PyArrow is 8.0.0. So this confirms that my installation has been done successfully and all the dependent libraries are installed. Good. If I have to check there is any older or outdated version of the libraries, I can run this command pip list --outdated. Let me run that. So it says my PyArrow having a latest version, and if I want, I can upgrade that. However, for the Snowflake Python connector, if I upgrade that, it will not work. So now my installation is done properly. So before we go and understand how we can write a Python program which can interact with Snowflake, let's try to validate whether this installation is really able to import the library or not. Let's go to the Python console. And then first I will import the Snowflake library. So now I can see my import has not ended with any error. It means the Snowflake connector library is available in my Python virtual environment. Now we will see how to write a simple Python program and interact with our Snowflake cloud data warehouse system. Let's start with our first Python program and understand how to obtain connection objects followed by cursor object and run a simple query and print the result on the screen. So here is my first Python program known as Snowflake Python.py. Let me shrink this project folder. So the first, on the line number 5, we import the Snowflake connector as SF. You can choose to have any name. Once my import is done successfully through this library, I establish a connection by calling a connect method. If you look into the argument, this is a keyword based argument. It means you can give the name of the argument followed by its value. From line number 14 to 19, I am passing different input. User ID, password and account names are must input parameters. Warehouse, database and schema are optional. This is a simple authentication mechanism where I need to pass user ID and password. This method returns Snowflake connection object, and if this method goes successfully, then we should be able to use this object to fetch additional attribute values. From line number 22 to line number 28, I am using this SF connection object and trying to print different attribute values. For example, account, database, schema, warehouse, and application. On the line number 23, I'm trying to print the SF connection object type. Now we have got the connection object. From the connection object, we are trying to call a method called cursor, and this returns a Snowflake cursor object. We are using the type method to understand what kind of object it is. Now, using this cursor object, you can use the execute method and pass a string as a query, and you can run any kind of query through this method. I am executing a simple SQL statement which tries to fetch current database, schema name, warehouse name, version of Snowflake, current account, and current client. Your current client print will come as a Snowflake connector for Python. If line number 40 gets executed successfully, then on the line number 45, we can fetch the result from the cursor object. I can use fetch many or a fetch one or a fetch all. There are different methods supported by the cursor object. Now I am fetching only one single row and I have a total 6 columns available in my select query. I am using the index to fetch the result one by one. Once I extracted the information, then I should close my cursor object and then I close my connection objects. So this is how this program looks like. Now let's run this program. So it did not take much time to fetch the result, and let's understand line by line. So here I can see this statement is printed here, creating a Snowflake connection. And once this line number 13 to 20 executed successfully, it printed connection established successfully. Here it is connection established successfully. And finally, on the line number 23, it is printing the object type. And here I can see the class is snowflake.connector.connection, Snowflake connection. Good. And then here it printed all the values starting from account, database, schema, warehouse, and application, which is matching these things. And you see the application is nothing but a Python connector. All good. Here I got the cursor object, and here the cursor class is snowflake.connector.cursor.snowflake cursor. All good. Now it is ready to execute this query, and here I can see this print statement. And once this gets executed, this is the line which is 46 to 51 is being printed. SDB schema, test schema, compute warehouse, and the current version of Snowflake is 6.30.0. And this is my account, and this is my Python connector 2.7.12. So this is how you can interact with your Snowflake data warehouse and execute any kind of queries and fetch the result on your local machine. Next, we will quickly understand how to use key pair based authentication mechanism. We have already seen this program in our previous chapter. The link is given above. Key pair authentications are very helpful in case you have to access your Snowflake environment via single sign-on as well as with multi-factor authentication. In such case, key pair based authentication comes handy. To support key pair based authentication, you have to import additional libraries as given here. They are all cryptography libraries which you need to import. Then you open your RSA public key followed by your private key. Once you have your public key and private key, pass the private key to establish a connection, right? And once you establish a connection, then you would be able to get the cursor object, and through the cursor object, you can do the same operation what we have done in our previous section. If you are confused how this thing works, please drop a note in the comment section, or I would recommend you to watch my previous chapter where we have executed a Python program to connect to the Snowflake. Now, let's say I have to create a bunch of table and also insert handful of record into them. Can I write the same Python program, or do I need to follow a different API calls? So let's understand this problem statement. So line number 8 gets a connection object as we have done earlier. And on line number 20, we are fetching the cursor object from the connection object. Once I have the cursor object available, I can call the execute method and create a table or any kind of object. In Python, I don't have to use different methods for a DDL or a DML. So line number 26, I am calling execute method and passing this create statement. Once my table is created, which I am calling test table, then I execute an insert statement. You can have the insert statement dynamically created and then pass the string into this execute method. For a simplicity, I have just embedded the entire string here. And the statement says insert into test table followed by values. And again, I am calling the same execute method as I have done it for DDL. Once the data is inserted into the table, then I am calling again the execute method and executing a select statement. Okay. Once the select statement is executed, I am validating the first row whether the record got inserted or not. Let's run this program. So it printed the record 1, 2, 3 and test string 1, which matches 1, 2, 3 and test string 1. Let's go back and see in our Snowflake console, how does it look like? So when I executed a select star from test table, I got 2 rows. Okay, so it worked successfully. Let me switch to my history tab. And here I can see the Python connector 2.7.12. Your query history client information column will tell you what kind of connector and which version of the connector is being used when you are interacting with your Snowflake. Good. The Python connector has a method called execute many, and in this section, we'll try to see how this function can be used. There could be a scenario where your records are available in an array. You want to use that array to insert the record. How can we do that using execute many method on the cursor object? So I got my connection object, fine. I got my cursor object, looks good. And once I got the cursor object, I'm creating a table called py_table02, and it has 2 columns, name and skill. And on line number 33, I have created a list, and the list is nothing but a collection of name followed by the skill. Now I would like to use this list object and run an insert statement. For that, Snowflake Python connector provide a method called execute many, where I am creating a placeholder. The placeholder should match with your data type. If you give question mark or something like that, what we have seen in Java, it does not work. If you try to use a statement like this, where placeholders are represented with a question mark, you may end up with an error. So finally, my insert statement looks like this, and then I am passing this list. And this is executed. And once it is executed, I am calling the execute method once again to run a select statement and finally printing the values. Let's run this program. So I can see total 3 rows inserted, and that is what here, like John, Alex and Pete. And I only printed the first row and the second row, and that's what the John and Alex, these results are appearing here. Okay, let's go back and check in our Snowflake. And I can see these 3 records available on my screen. This is how you can use execute many method from your cursor object. The Snowflake Python connector has a method called execute async. Let's understand how to use this method. There could be a scenario where your query is taking quite a long time and you don't want your Python program to wait for it. Cases like that can be handled using this asynchronous query execution method. Okay, let's understand how does it work. So line number 13 gets a Snowflake connection object. Line number 24 gets a cursor object. And from line number 32 to line number 38, it's a query which takes quite a lot of time. And let's see how much time does it take in our Snowflake UI. Let me run this query. So it took roughly 3.65 seconds. And let's say that you don't want to wait for this query to get finished and you want to come out of your program even before that. Okay. I don't want to run the same SQL and I'm going to change this by this. And here I will give as CNT. Okay, good. So once my query is executed asynchronously, I have a method called sfqid, which fetches the query ID from this cursor object. So I will get it printed and then I will allow my Python program to sleep for a 10 second. And then here I am also going to print the start time and end time. And finally, I will try to get the status of my query through my connection object. So this is the program and let's see the behavior of async query execution. So my query got executed and I got the query ID. Now my Python program is sleeping for 10 seconds. And I can see my query status is success. There are cases where you want to run a lot of complex queries which takes a little longer time. However, you don't want your Python program to wait for that long. You can capture the query ID and you can run another Python program later considering those query IDs and check the status whether the query got executed successfully or not. Let's go and search this query on Snowflake. So here I got the query ID. It took total 1.2 seconds and it clearly says that it got executed through the Python connect. Okay. The next question you will have in your mind that how to get the Snowflake data into Pandas data frame. Okay, so this program will help you to understand that concept. So from line number 12, we are getting the connection object. On line number 23, we got the cursor object. And on line number 30, we executed the same query what we did it last time. And finally, we got the result using a method called fetch many, where we have specified that we want only first 5 records from the result. Okay, so far everything looks good. Line number 40, we tried printing the length of the result, which will give us 5. And here we can also use a method called description from the cursor object, and that will give you all column names. We will see it when we run the program. Now, if you want to really get a data frame through this result object, we will try to print result object. And using this pandas.data frame, by passing the result, you would be able to convert into pandas data frame. And then you can do anything using this data frame. Okay, so let's run this program. So I can see the total 5 rows. Here it says the 5 rows, and before that it should tell us what is the data type. And here this is nothing but a list object, and from the list object you can really create a pandas data frame. And here when I say print description from the cursor object, it gave me all the data type including other information. And I can also say df.info, and this is the result from that df.info. And finally, when I say print df, all the 5 rows on the screen. So this is how you can convert your Snowflake result into a pandas data frame. There is an alternate way to fetch the data directly into pandas data frame, and you can call fetch pandas all or fetch pandas on batches. Probably we will see this method in a separate video. For now, we will limit our scope is to convert the Snowflake result into pandas data frame. So we have understood how we can interact with Snowflake and execute different kind of SQL statement, be it DDL, DML or asynchronous queries. What if I have a use case where I have to bring an automation using a Python code and load a lot of data into an stage environment? So let's see how we can use the same execute method on the cursor object to run a put command and load our data from our local machine or any server to the stage environment and run a copy command to load the bulk data. Here we get the connection object, and once our connection is successful, we get the cursor object from line number 24. Now we would see how we can load data from our local environment to the Snowflake stage environment. Before we really run a put command, I am going to create a file format which is called CSV file format. Let's see how the file looks like. So this is our file which has employee ID, employee name, email and SSN, and it has total 30 records. All good. So I am going to create a file format called my CSV format. I am going to call this create or replace file format using the same execute method. It will skip the first row as a header and it is a type CSV. Once I execute this create file format SQL statement, I will record the query ID. After creating my file format, I am going to create a table called employee table, and it has a total 4 column: employee ID, employee name, employee email and SSN number. Here I can again try to print the ID. This will give us a new ID because this is a separate SQL statement. Okay. Now once my file format is created and table is created, I am going to call a put command through the same execute method. I am giving 2 additional parameters. Have the autocompress equals to false and override equals to true. If you have not seen my previous chapter where I have covered how to use put command from your local environment, I will request you to watch that chapter. The link is given above. Now I'm trying to fetch the query ID for put command. So when I'm placing this file, I am placing the file in my table stage. If you have not seen my previous chapter, I will request you to go and watch that chapter. This will help you what is the user stage, table stage, internal stage followed by external stage. So now on successful execution of a put command, my file will be placed inside this table stage. On line number 55, I am executing a copy command, and the copy command will move the file from your table stage to the actual table. And I am using this file format, my CSV format, as a file type. Again printing the copy command object. Once the copy is done, I am trying to fetch the first record using fetch1 method. Okay. Finally, I am closing the cursor object followed by connection object. Before I run the program, let's see whether I have any table called employee table in my database or not. So I am in my test database and test schema, and I have only 2 tables. If I try to run select star from employee, I do not have any employee object. All good. Let's switch back to VS Editor. So I can see all of them are executed. Let's go back and see whether the employee table is created and the data is loaded successfully or not. I can see total 30 rows. And when I run list @%employee, which is a table stage, I can see the employee information file is available here of size 1584. Using this simple Python program through Snowflake Python Connector, you can really automate a lot of things and make yourself more and more productive. Now you know how easy it is to work with the Snowflake connector for Python and bring a lot of power to your team and build many automation utilities. Your existing data work stream can also be enhanced without much effort with Snowflake Python connector. Now you may ask a question. Using Python connector or Java JDBC driver, we have done a lot of data loading and transformation, created different kind of data models for final consumption. Can I use any BI tool to build a dashboard? What about Power BI Desktop Edition, which is free for our Windows operating system? And what about building a simple monitoring dashboard using Power BI and monitor your one or multiple Snowflake instances? So don't forget to watch the next chapter, which will help you with a nice report and a dashboard on the top of your Snowflake data warehouse instance. I hope you have been enjoying the Snowflake learning series, and if there is anything good in this video, press the like button and leave a comment.